was always been interested in math and sciences as a youngster, so I kind of gravitated towards engineering. I started doing a PhD at Southampton University, looking at aeroacoustics and noise of aircraft, really. It's very important to think about noise for smaller products because you often have these products within confined spaces. So if they generate excess noise, it can be very annoying to users. So the challenge of making products quieter is that you have to balance different forces, basically. It's easy to make it something quieter by just reducing its performance, but this is a compromise. What is really needed is to understand what mechanisms are responsible for generating that noise. In case of sort of floor-generated noise, you need to understand the floor physics that are involved in generating that noise. And when you do have that understanding, then you can really tackle the source itself rather than just mask the result of the noise. And this is where I think simulation tools play a big part. The challenge with noise is that we obviously can go in an acoustic chamber and measure the noise that a product produces. However, what you're missing there is some understanding of the mechanism that's generating that noise. When you use power flow simulation, what we start to get is a good understanding of that transient flow field inside our products and how that transient flow field generates noise. We can then start to think about ways to change or redesign our product to reduce that effect of noise. We started working with SIMULIA software about 3 years ago. So we have projects that are running at quite a pace, and we need tools that can provide us that insight at the right time. PowerFlow helped us in that area. We could turn around a high fidelity simulation of our motors within a couple of days compared to where our previous tools where we spend about weeks to do the same work. The really detailed insights we got from PowerFlow were very important. And the fact that we didn't have to compromise the details of the geometry to get our solution gave us more confidence that we're capturing all the pertinent details that generate noise in our products. Our vision is to sort of have almost a virtual prototype of our products as it comes up in the concept stages. So we can run simulations to understand what the performance, aerodynamic performance and acoustic performance will be before we have any physical prototypes. I love simulation because of the insights that we can get from simulation that are not obvious when we do measurements.